Hello, hello, geometry. Here we go. We're going to go through the practice test. In case you have questions, my numbers might be different than yours. I can't control what Math Excel gives you. So if your numbers are different, just kind of use the technique to answer any questions that you have. The measures of an interior angle and exterior angle of a regular 18-agon. I would start with the exterior, you guys, because that's always a sum of 360, and divide that by 18, and you get 20. All right, and then if you just supplement that, these two are supplementary. And so this is going to be 160. If you didn't go this route and you just went an interior angle with the formula, you would do 180, basically the sum, 180, 18 minus 2, which is 16 over 18, and you would see that you get 180 times 16 divided by 18. You would see that you get that 160, confirmation there. All right, some of the measures of a triangle. Wow, that's really too easy. But again, if you're doing the sum, you do 180, and then you do the number of sides, always minus 2. Always minus 2, so there you go, 180. We already know that from the triangle sum theorem. Find the angle, some of the angle measures of a decagon. So sum is just 180, and dec is n equals 10 sides, so that's just 10 minus 2. So 180 times 8, 180 times 8. We're just going to get 1440 here. 1440. All right. Find the measure of one interior of the polygon, 1, 2, 3, 4, 5, and it's regular, so we can find one interior. So an interior angle is going to be sum 5 minus 2 and then divided by 5. So that's going to be 180 times 3 divided by 5, and we get 108 here. All right, 108. Okay, you could have gone the exterior angle route if you thought about it and done 360 divided by 5, which is 72, and then you can see that those are supplementary. Okay, find the measure of each angle x in the figure. Okay, so we got to add all of these up. 125 plus 135 plus 127 plus 122 plus 125 plus 131 plus x has to equal some result here. Okay, so this is 1, 2, 3, 4, 5, 6, 7. So the sum of all of these guys is going to be 180 times 7 minus 2. All right, 180 times 5 is 900. All right, and okay, so we got 125 plus 135 plus 127 plus 122 plus 125 plus 131 is 765 plus x equals 900, and x is equal to 900 less that answer, and we get 135 here. Okay, and so 135, 135. Moving right along. Okay, the sum of the angle measures of a polygon with insides is 280, find n. So we're going to go in reverse here. We're going to take the sum, okay, we're going to take the sum, divide it by 180, and then add 2. Take that sum, divide it, instead of multiplying by 180, instead of minusing 2, we're going to add 2. So this is, comes out to 18. Okay, find the angle measure, or sorry, find the value of each variable. Well, okay, those are just going to be supplementary, so that's going to be 180, right? You got your calculator, you can do that in your head, but there you go. That's just going to be 71 right there. So that's C71, and so we'll write that there. And then we got to find y. This is all of these 4 angles are going to add up to, hopefully we know this. That's going to be 180, 360, right? 4 sides minus 2. That's going to be 360, just like a square or a rectangle. All of these are going to be 360. So we're just going to take 360 and minus off the 104, minus off the 81, and minus off the 71, and get our y value. So 360 minus 104 minus 81 minus 71, and we get 104 here. Okay, so 104 equals y. All right, hope we're all doing okay so far. Let's see, what do we have here? The measure of an exterior angle of a regular polygon is given below. Find the measure of an interior angle and then find the number of sides. Okay, so the measure of the exterior angle is here, and so the interior angle, those are going to be supplementary. They are supplementary. Supplementary. So we're just going to do 180 minus 36. Get our 144 right there. Okay, and then how many sides does the polygon have? I would just do 360 divided by that exterior angle, and that will give you n. So that's just 10. That's the easiest way to do it. 10 there for the number of sides. All right, I think we're out of 6.1 now. Use the diagram to find the measure of angle D. Okay, well, these consecutive angles in a parallelogram. I know it's a parallelogram because I see those marks. They're going to be supplementary. 180 minus 117. You can do this in your head also. 63 degrees. 63. Okay, let's see. What are we doing now? We're going to find x. So opposite sides are congruent. So 2x minus 5 equals x plus 4. X equals 9. Okay, easy algebra there. Find the value of x. Okay, these are supplementary, so they're going to add, what does that mean? Add to 180. Okay, and so 180 minus 67 is 113. Okay, that page is done. Where are we? Number 12. All right, number 12, what do we have to do? Find the value of A in the parallelogram. Okay, so I kind of wrote this out to get us started. What's probably easiest is to set these equal. And so find A, we got A minus 1.5 is got to be equal to 20.5. So A is equal to 20.5 plus 1.5. So A is equal to, that's 22. All right, and now we just set up 2 times 22 minus 20.7, and that's going to be 23.3. I'm not going to do all the calculations on this. BC is just going to be 22 minus 1.5, so that's going to be 20.5 as well. And again, you could actually, if we feel confident about all of our answers here, we can just go ahead and do opposite sides are congruent because we know it's a parallelogram. Okay, and then AD is obviously 20.5. That is given. Okay, so you could sub this in and get your confirmation here as well. 22 plus 1.3 is certainly 23.3. Okay, or you can just, do these two and then, put them on the other side because opposite sides are congruent. All right, find the measures of the numbered angles in the parallelogram. We're going to look for our z's here. And so you're going to just see this z right here. All right. And so 1 is 31 degrees. Okay, and so we need to figure out what these are. So I'm going to have to do the triangle sum theorem here. 180 minus 31 minus 117. 180 minus all that. 180 minus 31 minus 117 is 32. Okay, so that angle 2 is 32, and then by this alternate interior angle, you can just cruise right up there and get 32. Okay. Next piece here is use the parallelogram to find BAD. All right, so BAD is right here. Okay, so it's a parallelogram, so I'm liking this problem. I'm seeing alternate interior angles. And so BAD is just going to be the same as 25. There's that Z right up here, 25. All right, for what value Y must L, M, and P be a parallelogram? All right, well, these have to be supplementary. So 180 equals, 68 plus y. So 180 minus 68 equals y, and we're going to get 112 there. Okay. So remember, the quiz isn't all these. There's only like 15 questions on the quiz. For what value of x must we have a parallelogram? This is showing some diagonals being congruent, so we're just going to set those diagonals equal. If it's a parallelogram, diagonals must be congruent. X is equal to 6. Here, opposite sides must be congruent. They gave you these markings. We don't even need that. We just need the two sides. Kind of too much information there. 15x minus 11x and 9 plus 7. 4x is 16. X is then 4. Okay. For what value here must we be a parallelogram? Well, this is just alternate interior angles. So those are actually going to end up being congruent. Not really so much the property of a parallelogram, but more alternate interior angles, using the fact that these are parallel lines. Okay, so that's the z that you find there. Okay, so 15x minus 7 equals 11x plus 1. 15x minus 11x equals 7 plus 1. 4x equals 8. X is equal to 2. X is equal to 2 right there. Can the following quadrilateral be proven to be a parallelogram based on the given information? Explain. Okay, so we got one pair. Oh, can't even see it. One pair of opposite sides congruent. So that's good, but we need two. So it's either going to be A or C. No, it cannot be proven because at least two of the adjacent, okay, what, adjacent angles, that doesn't even come in. It cannot be proven because it only has one pair of opposite congruent angles, and so C is our selection. Okay, so read those carefully. All right, done with that page. Complete the following proof. Okay, so the sum of the measures of the angles of a quadrilateral is 360. Okay, what do we do when we combine like terms? We talked about this before. Whenever you're combining like terms, the reasoning is not combining like terms. It's the reverse of the distributive property. So whenever you see combining like terms, reverse of the distributive property. And then it looks like both sides were divided by 2. So that's your division property of equality. Okay. And then it says that A and B and A and D are supplementary then. And so that's the definition of supplementary. So basically here, if you've got that x plus y is, if you've got that x plus y is 180, that is going to make this x and this y, right? And so that's going to mean that these guys are x plus y as well. And so we get all of this supplementary stuff going on. But that one's filled in for us, definition of supplementary. All right. Well, AD then is going to be parallel to BC, and AB is going to be parallel to CD. Okay? And so that's because you have these parallel lines, right? And if you have these being supplementary, those are same side interior. Okay? And then the same thing here. If you have A and D, if you have A and D being supplementary, and look at these parallel lines, then, and these are supplementary, then those are same side. So that lets you know that these are indeed parallel because same side interior angles are congruent. All right, so what did we fill in? BC here. What did we fill in here? CD or DC. Doesn't matter the order. And if same side interior angles are supplementary, then the lines are parallel. Okay, and so we know we have a parallelogram because we have we know the definition of a parallelogram. Okay, so just talk yourself through a proof if you have it. I kind of set this one up for us too. Show that the quadrilateral is a given. Show the quadrilateral with the given vertices is a parallelogram. Okay, so we just got to compute all of these sides and see that if we get opposite sides congruent. So let's go AB first. I've got what, -4 minus -2. So -4 minus a -2, and then 4 minus 0. All right, so -4 minus a -2, that's going to be zap. I mean, really, those are just two units apart. So -4 minus a -2 is -4 plus 2, which is -2 squared. And this is just 4 squared. So this is 4 plus 16. This is 20 under the root. Okay, so we want to think of that. Don't have a lot of room here, sorry. We want to think of this as 4 times 5 or 2 root 5. All right, so that's AB. Let's go over to CD, and that's 0 minus 2 and 3 minus negative 1. So this is going to be negative 2 squared. That's 4. This is going to be 3. This is going to be 3 plus 1, which is 4 squared. So this is going to be 4 plus 16, which is root 20, which again is 4 times 5 under the root. And you can take that root, right? That's 2 root 5. Okay, so that's AB, 2 root 5, and CD or DC, 2 root 5. So far, so good. Looks like we're going to have us a parallelogram. All right, so B, negative 4 minus 0, and 4 minus 3. So this one is negative 4 squared, and that's just plus 1 squared. So this is going to be equal to 16 plus 1. That's going to be root 17. That can't be simplified. Okay, and then AD here is going to be negative 2 minus 2. Okay, that's negative 4 squared. And then 0 minus negative 1. That's just going to be plus 1. So again, we're going to get 16 plus 1, which is root 17. So, woohoo! The quadrilateral is a parallelogram because opposite sides are congruent, shown by coordinate geometry. All right, PAC is a parallelogram, and PAC is 111. PAC is 111. 111. Find EPA. Okay, find EPA. Well, that is just going to be supplementary. So, supplementary. We're just going to go 180 less 111, and that is what's 9 there. Okay. Now I think we're into some, oh gosh, could you not see that? Sorry. That's easy though, they're just supplementary. 180 minus 111. All right. Solve using substitution. So we're just going to plug some systems here. We're just going to plug y into this bottom equation at y. So negative 20x plus 140 minus x plus 7 equals 0. Negative 21x is equal to, that's going to be negative 140 minus 7. Negative 21x is equal to negative 147. And we're going to get, it's going to be actually a positive 7 because that negative. This was also negative. Okay, so x equals to 7, and just resub that in. So what is y? Y is equal to negative 5 times 7 plus 35. Y is equal to negative 35 plus 35. Y is equal to 0. Okay, so that is, the point is 7, 0. So they would intersect if you graphed them. Solve the system by substitution. So we're going to just solve this. Write y into the previous one at y. Okay, 6x into the previous one at y. So what do we have? 7x equals 21. X is 3. So if you graphed these lines, they would cross at 3. And then let's sub that in. Y is equal to 6 times 3. Y is equal to 18. 318 there. All right, solve the system using elimination. Oh, this one's nicely teed up for us. We're just going to draw a line. We don't even have to scale it. That drops out, and we get 12x equals 36. Divide by 12, and x is 3. All right, and so sub that in into either one. It'll be the same. 21 plus 3y equals 27. Looks like my pen is giving out here. 3y equals 27 minus 21. 3y equals 6. Y is 2. set 3, 2 there. And then solve by elimination. So we're going to scale this one. It would be nice if this were -3 because they would drop out. So let's make it -3. All right, so this will be 3x plus 2y equals 11. And this will be -3y minus 15y equals -24. Those are gone. And what am I left with? -13y is equal to -13. When you combine those, y is equal to 1. So be careful. We solved for y first this time, so that's the second ordinate. And then let's plug it in. 3x plus 2 times y equals 11. 3x plus 2 equals 11. Minus 2 minus 2. 3x equals 9. X is 3. All right, there you are. There's your practice test, 20 minutes. Hope this helped those of you who needed help. And be ready to take that quiz in class this week. All right, bye guys.